question asks us to explain the statement, the more stable intermediate forms faster, using these reactions as an example and by demonstrating it on a reaction coordinate diagram. I've labeled these structures A, B, C, and D. Let's plot them on a reaction coordinate diagram and see if we can explain this statement. Reaction A, or starting material A and C are almost essentially the same energy. So we'll start with starting material A. The alkene reacts with HCl to form a secondary carbocation. A secondary carbocation is less stable than an alkene, so this step will be an uphill step. Starting material C will start at a similar energy and is forming a tertiary carbocation. A tertiary carbocation is more stable than a secondary carbocation, so the reaction to form D will form a more stable tertiary carbocation intermediate. If we look at the activation energies for each of these two processes, we see that the reaction from A to B has a large activation energy to form the secondary carbocation, and the reaction from C to D has a smaller activation energy to form the tertiary carbocation. Because the tertiary carbocation is more stable, it has a smaller activation energy and will form faster than the secondary carbocation. In a competition, if both of these starting materials were present in the same flask and we add hydrochloric acid, starting material C will react faster to form the tertiary carbocation. Starting material A will react slower to form the secondary carbocation. The more stable intermediate forms faster.